All right, guys. Happy, happy Wednesday. I really do apologize for being gone this week, guys, and it's actually looking like I'm going to be gone for a little bit longer than I expected. I'm still not 100% sure yet, but it's looking like at least through Friday now. Um, so hopefully I'm back with you sooner rather than later. You do have a test on Monday. No, I'm sorry, Tuesday is when you have your test. I wrote on the board, so take a look at that, some instructions. Also, guys, if you're confused, because I get it, I'm not here to answer your questions. It's a little bit harder to get answers here. Please ask another teacher. I've talked with all of them. They're all okay with you stopping in. They said, yes, absolutely, have them stop by, and I'll help them as best I can as long as they have the time available. All right, so be respectful, but go in and ask them. They will help you. They are more than willing to help you. I know this is kind of a weird situation at a weird time, but just my absence is not an excuse come test day for feeling not ready to go. All right, you have plenty of resources available to you here at Princeton, and even online if you so choose. Okay, so you have more than enough resources to feel comfortable going into Tuesday. All right. So today we're going to talk about standard deviation. We're going to find standard deviation and variance of a set of values. Standard deviation, I guess we'll get to it here. First off, variation, or measure of variation, it describes how the data is spread out. So sometimes, when we're talking like box and whisker plots and stuff, sometimes that box is super small, and sometimes it's pretty big and pretty spread out. And so that's kind of what we're measuring today is how tightly packed in is the data or how spread apart is the data. So we have variance, which this is a Greek letter sigma. You already learned it's uppercase version. I don't know why those two are related anyway, but we're using the lowercase version here. And variance is sigma squared. And that doesn't mean a whole lot to you, but if you see sigma squared, that's talking about variance. Okay. Now, just sigma is standard deviation. Okay, both of these things measure how much data values deviate from the mean or from the average. Okay, so we have our average. Sorry. And then if the data is really spread out, your standard deviation and your variance are going to be fairly large. Okay. Now, if it's all tightly packed together, then vice versa. All right. Some key concepts. So this is kind of the list on how to find standard deviation and mean. So first, you find the average, and that's denoted by x bar of n values of a data set. So if we have 10 numbers, then n would be 10, and we find the average of those 10 numbers. Then we find the difference between each value and the mean. So if we have a value, then we subtract the average that we get. Okay, then what we get as the answer here, we square it. And then of all of those numbers, we're going to average all those numbers together. And that finds us our variance. Okay, now in order to find the standard deviation, whatever we get for that number, we're just going to take the square root of it. That might leave you, looking something a little bit like this. Yeah, I don't know what's going on, right? Or maybe your face looks more like this at this point, right? So here's a chart to kind of walk you through it. And guys, to be quite honest, we're not going to use the chart we're not going to do it by hand. We have technology. I'm not going to waste our times filling out a chart. Okay, so but just to kind of show you what an overview of what it looks like. Sorry for this watermark down here. I don't have my smartboard connected to I don't have it connected to a smartboard, so that's why it's showing up. Okay, so if we had these data points, 6.9, 8.7, 7.6, 4.8, 9.0, we're going to add them all up. There's 5 numbers, so we divide by 5, right? We find the average, and that's 7.4. Okay, then for each number, 6.9, our average was 7.4. Okay, so here's the list of all the numbers. Here's the average, 7.4. We're going to subtract them. So 6.9 minus 7.4 is negative 0.5. Okay, then what we're going to do is we square it, and we get 0.25. Okay, same thing here. 8.7 minus 7.4 is 1.3. We square it, we get 1.69. Okay, we do the same thing for every other number here, and then we add them all up. Okay, now in order to find the variance, we're going to take that number when we added them all up and just divide by however many there were. So there were 5 numbers, so 11.3 divided by 5 is 2.26. So this right here is your variance. I know it's kind of hidden by the watermark, but you should have it in your notes too. Okay, so that number is your variance. Now in order to find the standard deviation, this number gets square rooted, and we end up with 1.5 as our standard deviation. Okay, now we're not going to do it. We're not going to do it with a chart because we're just not going to. Okay, so I'm going to kind of move this up a little bit. You don't have this in your notes, but I would highly recommend writing it down because this right here tells you how to do it on your calculator. Okay, and a little note over here. How do you know that you're entering all the data values? The value for n on the calculator should match the number of table values. Okay, so anyways, what we're going to do, you're going to hit Stat, Edit, and then fill in List 1. And then you're going to go into Stat again. This time go to Calc and select 1 var stats. Okay, so just write that down. I'll pause it for a second. Actually, just jot it down super quick, and then we'll move on to our problem here. All right, so we have a set of data, and we need to find the variance and find the standard deviation. Now remember, when we're going to use our calculator, and when I'm going to kind of jump down here quick. Our calculator is eventually going to spit out a table like this. Okay, and this number right here, the one with the sigma x, that's going to be our standard deviation. Okay, now to back up to where we were, the calculator will give us standard deviation. How do we get from standard deviation to variance? We were going to square it. Okay, so whatever number we get, we're going to square it, and that'll give us our variance. All right, so let's turn over to our calculator. I already wrote down the numbers because I'm going to be switching screens, but you have it in your notes. So make sure you have a graphing calculator. We need to use them today. Okay, so what we're going to do, you're going to go into Stat. Let me get out of that. Oops, let me get out of that screen here. All right, we're going to go into Stat. Stat is right next to your arrows. Okay, so hit Stat, and then it's already on what we want it to be on, Edit. So we're going to edit our table, so just hit Enter. And it should bring up a list. Now yours may be blank, yours may have numbers in it, I don't know. Okay, what we're going to do, and I wrote down all the numbers, you have them in your notes, go ahead and just enter them in. So 4, 12, 7, 18, just keep going until you get them all in. Oops, make sure your numbers are right. I made a mistake here. All right, now when you get done with the 7, make sure you hit Enter, just to make sure that 7 is counted. It should be, but I just want to make sure that we have everything counted here. So your list should look like this. Now we're going to hit Stat again, but this time we're going to go over to Calc. And 1 var stats is right on top, and so we can just go ahead and hit Enter. And it's going to ask us, do we want to do list 1? Yes, we do. If for whatever reason it's on list something else and we want to switch lists, down here on your number pad, you see up above them, you're going to hit second and then whichever number you would like your list to come from. Okay, so you can change it that way. But our list is good, so let's just hit Calculate, and it'll spit out all these wonderful numbers. Now, this number right up here, that's the mean, that's the average of all the numbers, 13.1. This right here, 184, is the sum of them, the sum squared. Okay, now this sigma x, that is our standard deviation. Make sure you round properly. 7 point, let's go out to hundredths here, 7.57. Okay, is our standard deviation. Now, real quick, if you scroll down, your project, you could have used this and it would have calculated your quartile 1, your median, and your quartile 3 all for you. But anyway, you didn't know about that. So, all right, our standard deviation is 7.57. Make sure you round properly. 7.57 is our standard deviation. That number gets squared in order to get us our variance. And so 7.57 squared is 57.30. We'll call it 57.3. All right. Same thing with this. Now, just for the sake of time, I'm going to skip this one, but it's another practice problem for you in your calculator. Now, here we go. Use the standard deviation to describe the data. We need to figure out within how many standard deviations from the mean do all of the values fall. Okay, so we have all of these numbers here. 19, 15, 20. Now let's figure out what is our minimum number here. 15 so far is the smallest. 13 is now the smallest. 12 right here. And our biggest number looks to be 24. Okay, so we need to figure out from 12 to 24. Okay, where's our average? And how many standard deviations away from the average is it, or are all the numbers contained? All right, so I'm going to pause the video, go ahead and enter in all of the strike numbers, enter them all into your calculator, and run the test. All right, so on your calculator, you would have gotten the same thing that's actually on the slide, but I wanted you to practice. Our mean is 17.6. Okay, so let's just go ahead and plot that on our number line. 17.6 is our mean. 17.6 would be probably right about here. That's our mean. Okay, now our standard deviation was we'll call it 3.5. And so 3.5 away from that would be so we have 17.6 plus 3.5. And that gets you, my brain's not working today, I believe it's 21.1. 17.6 plus 3.5. Yeah, 21.1. Okay, so here's 21.1 would be right here. After one standard deviation, so all the numbers in this range are within one standard deviation. And then also we go down this way, 17.6 minus 3.5. It gets you 14.1, so down here. And so everything this far is one standard deviation away. Okay, now we don't have all of our numbers included, right? Because 12 and 24 aren't included yet. So let's go another standard deviation. Okay, so I'm going to subtract another 3.5, and that gets me 10.6, which is like right here. Okay, so this is another standard deviation. So we're 2 standard deviations away from the average. And this is included, so that's looking positive. Now from here, we had 24.6, which is probably right here. Sorry for my watermark. So we've added 3.5 twice from the average, and that gets us, all of our numbers are included now because these were our extremes. And so to answer our question, 2 standard deviations. Okay, real quick, this is your homework. I can go ahead and pause the video here.